guess it's on. Okay. A few comments. One, we're in a geoengineering experiment right now. We've been that ever since we decided to heat the oceans. Okay. And so what this is all about in the physical sense is we're changing the energy pathways of the planet. Now there's an interesting moral perspective which you will get to deal with in your last presentation about whether species should be doing this to their planet. I'll just leave it at that for now. But we're in a geoengineering situation right now at a scale that was never predicted. And so now we want to try our geoengineering way out at a similar scale but with a faster correction time. Okay? You can make many very bad and even some good science fiction movies about this. So of the three solutions that you heard today, which one do you think has the biggest probability of a catastrophe, an actual catastrophe?
Stratoshield.
And why do you think the stratoshield is the most prone
because
to a catastrophe?
it affects all systems on the planet.
Well, but so does all of these things affect all systems on the planet.
Irreversible.
Most temperamental.
These are all qualitative things. Yeah.
I mean, I kind of feel like it's the ocean fertilization. No offense. You guys
You
plan
can
is great.
offend anybody you want.
But once you put the iron down, it's like in there, and you have no idea how the system's going to
All
grow
right,
around.
hang on. Let's divide this into short-term catastrophe and longer-term catastrophe. So hold that thought with respect to that. Stratoshield has a potential short-term catastrophe. What do you think that might be, and how might it be caused?
Blocking too much sunlight.
Exactly. Too fast. So what the Strato team presentation did not tell you was I'm not even sure you could have found this, was what is the rate of sulfur injection needed? Do you just want to instantaneously, what does Pinatubo do, right? It instantaneously releases sulfates into the atmosphere with a residence time of 18 months that produced a global cooling of about 1 degree C, right? And, you want to produce a global cooling on order of 2 to 3 degrees C for similar magnitude. And so you're talking about trying to time the sudden injection of stratospheric aerosols to rapidly reduce this reduction. So it's taken us 150 years to get to about plus 2.2 C now. We don't want to wait 150 years to go to zero. The Stratoshield people want to push it to zero essentially as soon as the shield is implemented. So that's why that one has the largest amount of catastrophe, because obviously what might happen?
The Earth is dark.
Well, Sherman even mentioned it in his rant. What's going to happen with Stratoshield?
I just mentioned
Yeah, talked about it.
Lisa says so much I didn't remember exactly.
You guys said in your presentation that all three of these things can lead to something else.
The Ice Age.
Yeah, they can all lead to global cooling. And that's the problem with the Stratoshield, is it can just instantaneously lead to global cooling. Now, long story short, because we'll talk about this a little bit more in the class, there was something they called the Little Ice Age that occurred, particularly in medieval Europe. And no one until very recently understood what caused it. Now we think it's been understood, as there was a series of 4 Pinatubo-like equatorial volcano explosions that went off over a period of about 100 years that kept reinforcing this, right? So that's the most dangerous one by far. Now, ocean, digging with the ocean. What's the longer term problem here? You were starting to talk about.
Yeah, what I was just going to say about it is that once you add the iron into the oceans, you have no idea how the system's going to react.
Yeah.
And there's no way to get it out, so it's a permanent effect. So if it ends up being bad, there's absolutely no way to reverse it.
And it's going to end up being bad on longer, thousands of years of timescales. And this issue of oxygen deprivation is huge. So I don't know how many of you, does anybody know how oxygen got in our atmosphere or why it took so long to get in the atmosphere?
Cyanobacteria started photosynthesizing and it caused the oxygen
Yeah, but why-
catastrophe, which killed a bunch of organisms.
Right, but why does it take so long for the oxygen? I mean, we can agree that photosynthesis, oxygen-producing photosynthesis occurred 3.8 billion years ago. Why does it take 2 billion years for atmospheric oxygen to rise? Something is preventing oxygen from getting from the oceans to the atmosphere. And that's all the dissolved iron, double plus iron in the oceans, which scavenge all the oxygen, settle down as red beds. And so, oxygen doesn't get to regular normal significant ozone layer for 2 billion years. So we already know that the oxygen evolution, ocean atmosphere coupling, is extremely sensitive to the amount of iron that's in the ocean. Extremely sensitive. And so this is the absolute really worst thing that we can do on the longer time scale, is this kind of stuff. If we're going to artificially increase the amount of iron in the ocean by a factor of 2, essentially instantaneously, right, that's another one of these catastrophes. So the interesting thing so why is surface reflectivity then a potentially pragmatic approach? Yeah.
Because we can control the land use change.
Right. It's something that's more controllable. You can see if it's having any effect sort of along the way and try and figure out. But the problem is it will not be fast enough to actually do anything. And so in the real world, we have two choices. We have to view climate change as this adaptation event that's going to run its course when we have burned all our fossil fuels. Okay? That, I believe, is what's really going to happen. And the severity of this will depend on the clouds. Now, no one talked about the cloud problem. All right? What happens if I build my stratoshield and it's in place and then all of a sudden the Earth decides to get more cloudy?
And just stop burning.
Right. And so the cloud acceleration in the global cooling can be greatly enhanced by any of these attempts to change the albedo. Any of these attempts. And so all of that's, we don't know what the clouds are doing. That's a hard problem. But the surface reflectivity things can make small differences. I mean, there's a lot that we can do right now at the level of sort of less than 1% changes, which could be significant. So either we're just going to reach 1,000 parts per million at by 2100 and have burned out most of our fossil fuels and have all these environmental whatever adaptation stuff, or we can actually start to more seriously do carbon capture and storage by ignoring the economics of it. But if we don't ignore the economics of it, then it will never get done. So ultimately, all you economists over there, you already told us about $7.9 million is the average cost of a human being, okay? What's the fucking cost of a broken planetary ecosystem? Okay? Give me a number. What is the cost of eliminating half of all the species in the ocean? Give me a number. But a number has to be given for that because that's the only way to respond. So the only way we start to become proactive on a significant scale is when we have an economic framework and a global accounting mechanism for countries to contribute to that. So that's your generation's challenge, by the way. So that's why y'all need to go to law school, go into international law, and kick the ass of the rest of the world. So I actually thought this stuff went really well. It went a lot better than I expected.
Yeah.
Yeah, we may do the last presentations in here. All this is on YouTube, so we'll be out there. So yeah, well done.
Okay.
No. Not even close. So, you guys are having your group meeting here on Friday, right?
They did last Friday. I wasn't here, so.
They didn't have it in here.
Huh?
They didn't have it in here.
They came down at some point.
Anyway, I told Jordan I'd help him out a half an hour Friday before the meeting.
Cool.
But what? You have image data you want to show?
Depends on who's presenting.
Well, what format is he?
Any format. So we use Fiji, like ImageStream, which is installed on here.
Okay, a lot of stuff used to be installed on here that's not installed on here anymore, so you need to find that out.
Jordan's talking to Jamie.
What?
Jamie, Jesse, his librarian. That guy.
Yeah, Jordan needs to talk to Peter Vesse, but I'll point him in that direction.